Hi, this is Mr. McGovern and welcome to the third video in the circular motion series where I'm going to talk about the difference between centripetal and centrifugal. So centripetal, we learned in the second video, is just a name or another name for the total force in circular motion, and it's really important to realize it's not another separate force. Okay, our forces of tension force, gravity force, normal force, friction force are actual forces. You combine them together to find the total force. In circular motion, another name for this total force is centripetal force. So when you've got these situations where we had the whistle on the string going round and round, this is the bird's eye view of it, and a car going around a circle, you need to identify the actual force responsible for making this thing travel in a circle. With the whistle, it was the tension force, and with the car, it's friction force. Okay, if friction disappeared, the car was on ice, it would not be able to travel around in that circle. Centrifugal, on the other hand, is a word that means the apparent force you feel when you yourself are undergoing circular motion. So I've got a picture here of a boy going around rather quickly on a merry-go-round, and he feels like he's being forced outwards on that merry-go-round. I'm sure you've been on one of them before where your friend spins you too fast, and it feels like you're being thrown outwards. So how do we explain this? If I've told you that the total force is towards the centre, and yet you feel getting pushed outwards. The best way to explain it, I find, is if I think about a linear example of a car just going in a straight line. You're driving the car, or you're in the passenger seat, and the car accelerates violently. It accelerates forward quite quickly. What do you feel? Well, you feel your head feels like it's being pushed backwards into the seat. Okay? So, on the one hand, you know that the force is in the forwards direction because that's the way you're accelerating, but it feels like your body's getting pushed backwards, right? So you're feeling like you're being pushed in the opposite direction as you know the force is. And this is explained by Newton's first law, which is that objects at rest tend to stay at rest. Okay, so your body's at rest when you're sitting in the car and it's not moving. When you accelerate, your body wants to stay there, it wants to stay at rest. The car's moving forward while your body wants to stay still. And so that's why you feel pushed back into the seat, not because you've gone backwards, but because the seat's moved forward into you. The same thing can be applied for things going around circular motion. So objects at rest tend to want to stay at rest, objects in motion tend to want to stay in motion. And especially, well, not especially, but it's objects at a constant velocity tend to stay at a constant velocity. So the whistle on the string at this point, its velocity is at a tangent, right? And so it wants to keep going at that tangent. Now the string, on the other hand, forces it to go around the circle. So this is why you feel like you're being pushed outwards. If you imagine you are the whistle going around circular motion, your body wants to keep going out. However, the string pulls you in. So it's just like the acceleration of the car, where your body wants to stay still, but the car is trying to push you forward, and it feels like you're being pushed back. Here, you want to keep going in a tangent around the circle. Well, in circular motion, you want to keep going at a tangent. The total force wants to pull you in, and so it feels like you're being thrown outwards, even though the total force is inwards. It's a tough idea, centrifugal. It is a very tough idea. So the main thing I want you to take away from it is it's just the feeling you feel while you're in circular motion. It's not an actual force, okay? It's just a feeling. Centripetal, on the other hand, is the real force, and that causes things to undergo circular motion.